In this video, you will learn about basic image classification model in TensorFlow. You will learn how to predict a handwritten digit. I'll explain you here. We will have these images of the digits. These are all grayscale. We have 5, 0, 4, 1, 9, 2, 3. These are the handwritten digits that we want to predict, and we will use the TensorFlow to predict these images. And to know more about this dataset, we can go to its official website. And if you come here, you will see that the description of this dataset is given here. This is the MNIST dataset of handwritten digits, and it has a training set of 60,000 examples, and for test set we will have 10,000 examples. Now let us go in TensorFlow, or let us start our coding and see how we can develop this classification model. I'll import TensorFlow STF. You can also check the version of your TensorFlow, and to check that we will write tf dot, then you have to write dunder, then version, and then you just print it. My TensorFlow version is 2.3.0. This is older version. You might be having some newer version, but that's not an issue. Now let's import the dataset. I'll write from TensorFlow dot keras dot datasets import MNIST. The dataset name is MNIST. Now I'm going to make two tuples and then load the dataset into those tuples. First tuple will be X train and Y train. We will have training dataset in this first tuple, and they will be for X and Y. Then the next tuple will have test dataset, X test and Y test. I'll write here X test and then Y test. And then to load the dataset, we will call this MNIST that we just imported above. And from this, we will load a helper function which is load underscore data. Now this will load the dataset into these two tuples. Now we can look at the shape of this X train, Y train, X test and Y test. Let us see. Underscore train dot shape, and in training it says that there are 60,000 samples, and let us also check in test X underscore test dot shape. In test dataset we have 10,000 examples, and if I go to the official website, you will see here that it is saying here that there are 60,000 examples in a training set and 10,000 in the test set. So we have found out that we have similar number of samples in the train and test set. Now we are going to plot some of the images from our data set, and for that first I will import the matplotlib library. I will write import matplotlib dot pyplot as plt, and then magic command line percentage matplotlib inline. Now what I'm going to do is I'm going to display the first training example of our image. I will write here plt dot im show and then X train, and let us display the first image, and then I'll press enter, and I'll also write here plt dot show. The reason is you can see this one line here, and if I want to get rid of this line, then I'll just have to write this plt dot show, and if I execute the code, you will see that line is not there. And now you can see that we have this image and the digit is 5, but I have shown you that we have this grayscale image. Now to see this digit in the grayscale image, then you don't have to worry, you just have to pass one parameter. I'll put a comma and then I'll pass one parameter, and that parameter is cmap, which stands for color map. So I will write here cmap, and then this is going to be binary. Now you will see we will get the same image in black and white form. Now here in the output you can see we got the same image in the black and white because we have passed this parameter, the color map. Cmap stands for the color map, and we have said that this is binary, that's why we got a black and white image now. And similarly we can look at some other random numbers. Let's say 11. So here we have this image of 6, and if I put here let's say 100, Here we have image of this. I'm not able to guess. Let me print 101. So we have this 7, I guess, or if I put 2 here, this is 4. So these are some of the training examples that you can see. And now we will go to the next step where we will check the labels. So to check the labels, we will just use one set method, and I'll write here set of y underscore train. Now this will tell us the labels. So the labels present are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are total 10 images, and that's why the index starting is from 0. So we have this 0 from starting from 0 up to 9. These are the labels that we have. Now what we are going to do is, now we will do the one hot encoding for our labels for both train and test dataset. So we will do the one hot encoding here, and if I write here y train of, let's say, 0, so this says that this is 5. Now what we are going to do is we are going to apply the one hot encoding. So when we apply the one hot encoding, what will happen, that we will get 10 numbers here. So wherever the digit is 5, so in this train at this index number 0, the digit is 5, and if the digit is 5, then the number will be 1, otherwise all the numbers will be 0 after the one hot encoding. Now let us see how we can do that one hot encoding. To do that, first we will import from TensorFlow .keras .utils import to underscore categorical. This will help us to do one hot encoding. Now what I am going to do, I'll make two new variable, one for the train and one for the test. And what we are doing this one hot encoding only for the label variable. That is why we will apply this only on the y set, the y train and the y test, not on the x set, that is x train or x test. So I'll make y underscore train underscore enc stand for encoding. You can give any variable name. Then I will call this function to underscore categorical, and inside this I will pass y train. Now similarly I will do this for y test. So I'll copy this from here, I'll paste it here, and now instead of y train I'll write here y test, and here also I will write here y test. Now I have done this encoding. Let us look at the shape. I will write here y train underscore enc dot shape. So in training we have 60,000 samples and 10 classes, and in test we will have 10,000 samples. Y test underscore enc dot shape, we should get 10,000 only. Yeah, so we have this 10,000 samples here. Now let us display the encoded label. So I'll display the encoded label below this only. If I write here y train underscore encoded. Now these are the raw features and these are the encoded. So if I type here 0, now you will see here we will have this 10 numbers, 1 2 3 4 5 6 7 8 9 10, because there are 10 classes and we applied the one hot encoding. Now what happens after applying the one hot encoding, all the numbers will become 0, and the label where the actual value is present, that will be 1. And if I do this for, let's say, some other variable or some other sample, instead of 1 I will write here 10. So here also you will see we are getting 1 here in this index number 0 1 2 3. So we have done this one hot encoding. Now right now the shape of our input sample is 28 by 28. If I write here x train dot shape, you can see here the input shape is 28 by 28, and we need to change it to 784 so that our input will be in the proper format to train our model. We cannot pass this model as it is, it won't run. We need to convert this into a 784 size instead of this 28 by 24. Now let's do that. For that I will import numpy I'll write here import numpy as np, and then I'll make new variables, and those variables will be a reshaped one. So where we will have, instead of 28 by 28, we will have 784. So let's make that. I will write here, and this I will do for the x variable only, not for the y one. So I'll write here x train and then reshape. So this is going to be my new variable x train reshape. Then I will call here numpy dot reshape. I will pass here x train because I want to do the reshaping of the x train, and then I have to pass the sample images in a tuple. So in training we have 60,000, so we have 60,000 images, and the size that we want is, or the shape that we want is 784. So I'll write here 784, and I'll do this similar for the x test. I'll copy this and I'll paste it here. Now instead of train I will write here x test, and here also instead of train I'll write here x test. Now so okay, here I have to write 10,000, sorry, my mistake, because in test data we have only 10,000 samples. Now if I execute this code, so there's no error. Now we can check the shape of this. I will write here x train underscore reshaped, and this should be 60,000 by 784. So here you can see this is 60,000 by 784, and for this also we will have, if I copy and paste it here, and if I write here shape, this will be 10,000 by 784. So we have this 10,000 by 784. Now we can use these two data sets for training our model, and for labels we can use this encoded variables that we have created. Now you will see that there are different numbers, but if I write here x train dot reshaped, or let me write here x train dot reshape dot 10. So yeah, here you will see we have different numbers 0, 118, 219, 242, 254, and so on. So we have different numbers, but for neural network the model to learn weights and biases, and for computation also it will be very difficult if we have these raw numbers, which is 0 or 103 or 254. So we need to normalize these values before we actually train our models, because you will see here there is a lot of difference here, starting with 0 and then going up to 230, 254, 242, and so on. So it will take time for the computation also. So for the neural network to fit fast, and the computation also, the speed of the computation also, to increase the speed, we will normalize these values before we start training the model. Now what we will do is we will normalize these values, and for that we can use the mean and standard deviation. So first we will calculate the mean as standard deviation, and then we will normalize all our training data set. So what I will do, I will write here all our training and test data set also. So I will write here x mean, and then I will call np dot mean, and I want to find the mean of x train underscore reshape. What I am doing is, because we want to use these features, the x train reshape and x test reshape, for our training, for training our model. Now we are finding the mean of this x train reshape and also the standard deviation of this. I'll copy this from here, I'll paste it here, and then I will write here x standard deviation, and then here np dot std, which stands for standard deviation, and this is also is going to be for x train. I'll make one more variable epsilon, and I'll give this value 1e minus 10. We use this because sometimes the value of the standard deviation is very small, then it leads to instability in the computation, and adding another small value to it, it usually solves it. That's why we will use this value also for our normalization. Now what I'm going to do is I'm going to make two new variables which are going to be normalized, and let us do that. I'll write here x underscore train underscore nor, and then I will call x train underscore reshaped minus, now from this I will minus mean that we have calculated, and then I will divide it by standard deviation x underscore standard deviation, and then I will add this very small value of epsilon. Now I'll do similarly for the x test. I'll copy the code and then paste it, and instead of train I will write here test, and here also I will write test, and then let us execute our code. Now we have these two variables where we have the normalized value, and if I print x train underscore norm, and then I'll pass this index number which is 10 here. Now if I do that, let's see. Now if I do that, you can see these are the normalized value. All the values are, they are all same, or they are very close to each other. This is the normalized from our value. Now we have done this the normalization part. Now the next thing is that we will create our model. So we have done all the pre-processing steps, and before I create the model, let me tell you again what we have done. So we have imported this TensorFlow, then we have loaded the dataset into train and test, then we made this plot and saw some of the labels. Then what we did is we did one hot encoding for our labels, and then what we did, we reshaped our train and test dataset into 784, and after the reshaping we have done this normalization, and after this normalization now we are going to fit our model. Now to fit our model we will import some of the libraries. First we will import from tensorflow.keras.models import sequential. We will use this sequential model. Then we will also import from tensorflow.keras.layers import dense layer. We will import the dense layer also. I'll write here dense. Now let us execute our code. I have to delete one e, I'm sorry for that. Now I'll make one object. Let's create our model. So I'll make a model object. This is going to be my model object. Then I will call this sequential class which we just imported, and inside this I will pass all the layers. First layer is going to be dense layer, and then the first input is going to be neurons. So let's say I will pass 128 neurons. These are neurons of the hidden layers. Then the next is activation function. I'll write here activation, and there are many different activation functions, but in this tutorial we will use the relu. I'll write here relu. Then we have to give the input shape, that is the training model shape. I'll write here input underscore shape, and the input shape is 784. I'll write here 784. Then what I will do, I will add one more dense layer. I'll write here dense, and this time also 128 neurons or here hidden layer. Now activation function is going to be same relu. This time we don't have to give the input shape because we have to give it for the first time only, and now here the input will be nothing but the output of this dense layer will be the input to this layer. That is why we don't have to define the input shape here again. Now I'll add one more layer which is the last dense layer or the output layer, and here I will write 10 because we have 10 classes or 10 labels, and then activation function. So activation function will be different because we have 10 classes. I will use here softmax. So you have to understand that the activation function when you are defining a dense layer is different, and it is different when you are defining the output layer. So this is our output layer, and that is why we have 10 classes, and the activation function is also different. Now let us execute our code. Now we will compile this model. So what we have done is we have just defined the model here. We have done nothing. Now we will compile the model, and then after compilation we will train the model. So let's compile it. Model dot compile, and then inside this we have to pass optimizer. First is optimizer. So there are different optimizer that you can use when you are compiling a model. We will use SGD, which is stochastic gradient descent, and then we will also define loss, and our loss is going to be categorical cross entropy, because we have many categories here, 10 labels we have. And then we also need to define the metrics, and the metrics is going to be accuracy. We will check the accuracy of this model, so I'll write here accuracy. Now this is the loss function we need to minimize. So what we are trying to do in this neural network is that we are trying to minimize this loss function. This is like actual minus predicted value. This is what an optimizer or an optimization function does, that is it minimizes the loss. So this SGD, the stochastic gradient descent, will minimize this loss. Now let us execute our code. We have compiled our model. Now we can look at the architecture of the model. So that what we have created here is this model, the architecture, and we can look at the architecture by calling this model dot summary. And here in the output you will see this is the summary of the model. So first we will have this dense layer, and then the second dense layer, the third dense layer. These are the total parameters, and this is the architecture of our model. You can do the calculation and you will get these values if you want to do. I won't do because then the video time will become longer. Now what we are going to do, so what we have defined the sequential model, we have compiled the model, and now the last stage is that to train the model. So we will fit the model. I will call here model dot fit, and we will fit on xtrain underscore norm, because we are fitting on the normalized data set. And then in label we will have ytrain underscore encoded labels, and then we have this one term epochs, and let's say I will give it 5. So this means that we want to train this model 5 times. Let us execute our code. Now this model will start training 5 times. You will see here. So the 1 2 3 4, this is 1 2 3 4, and this is the 5th one. Now if you see here, in the first iteration the training the accuracy of the model was 89%, in second 94, 96, 96, 97. So after 5th iteration we see that the accuracy of the model increases to 97% from 89%. Now let us check the accuracy on the X test. So I'll make one variable accuracy, and then I will call model dot evaluate, and then we want to evaluate on X test underscore nor, and then Y test underscore encoding. We are evaluating this on the test data set. That is why I've written here X test nor and Y test encoding. And so here you can see the accuracy is coming to be 96%. It is close to the training accuracy, and this accuracy will improve if we run this model more than 5 times. So you can change the value of epochs here. You can make it 10 or 20. I'm not doing this because then it will take some time for the competition, and the length of this video will also increase. That is the reason. So you can change the epoch size, and you can try different epochs and see what accuracy you are getting in the train and the test data set. Now what we can do is we can make predictions and save in a variable. So I'll make one variable pred, then I will call this model dot predict, and then I want to make predictions on the X test underscore norm. And now let us print pred dot shape. So we have made predictions for 10,000 samples, because in our test sets we have this 10,000 samples. And if I write here pred of 0, so you will see we are getting these numbers here. Now what we can do is we can actually visualize these predictions. So let's visualize it. I'll make one plot. Let's say I'll write here plt dot figure, and then figure size figure size is going to be, let's say, 10 by 10. This is 10 by 10. We are going to plot the predictions. Then start index is going to be 0. Then I will run a for loop for I in range 25. We're going to plot 25 predictions. Then I will make subplot plt dot subplot 5 by 5 I plus 1. So it will have 5 predictions in a row and 5 in a column, total 25. Then we will write here plt dot grid, and this is going to be false. Then plt dot xtext, this is going to be empty. plt dot ytext, this is also going to be empty. And then I'll make prediction here, and what I will do, I'll make this as s. Here I will write here preds, and here I will write here pred. This is my new variable. So what I will do, I will use the numpy, and from that I will use the argmax, and I will find from this preds. So these are the probabilities. What we see here is, if we see, these are the probabilities. So you will have 1 2 3 4 5 6 7 8 9 10. So these are the probabilities for the 10 classes, and the class which will have the highest probability will be the predicted class for this index number 1. So what we are going to do here is, from this probabilities we are using this numpy argmax function, and we will find, or we will get the highest probability and save that probability in this variable pred. So I will write here start underscore index plus I, and then so we will have the highest probability and saved in this variable in pred, and then we will have this actual one, and actual one we will get it from ytest start underscore index plus I, and then we will plot it, plot x label, and then I will write here I, and then this empty, this is going to be empty, and then we have this actual, and we also need for pred. So I'll write here pred, this is going to be empty, and then here actual, and then I will I'll remove this code from here, and I'll put that here. I'll complete this code here, then dot format. So in our first this empty curly braces we will have, let's say we will write here start index, and then in the second we will have predictions, and the third one we will have the actual, and then we will show plt dot im show. I will write here x test, and then I will write here start underscore index plus I, and then I will pass one parameter cmap is equal to binary, and then I'll go out of this loop and write here plt dot show. So we got error here, start index I, and here I have to put n here. Now if I run this code, so here you will see we got the predictions here. Now you will see here, so we have this I is equal to 0 and pred is equal to 7, and actual is equal to 7. So these are the correct predictions, and let us see if there are any wrong predictions made somewhere. So we have this, every prediction is actual is 0, I is equal to 0, pred is 9, actual is 9. So all of this looks to be correctly predicted. But now if you want to see that, let's say why this number is predicted 4. So this is at index number 0, 1, 2, 3 and 4. So let us see what is the probability of 4. I mean what probability 4 got so that this number was predicted as 4. So let us plot this example to see. So what I will do here is I will write here plt dot plot and then pred and then 4 number. I'll write here plt dot show. So here if you see the probability of 4, you can see this is around 95-96%, and that is the reason this sample is predicted as 4 here, you know. So if you want to see why this number is predicted as 7 or 2 or 1, so you just have to type that index number. Let's say for this 0, we will type this index number 0. I'll write here as 0. So now if you see here, the probability for this class 7, this is between 6 and 8, this is here we will see 7 is around 98 to 9%. So that the probability of this sample being number 7 is around 98 to 9%. That is why this class or this sample is predicted at 7. So if you want to see other examples also, you can just take their index number and then you can plot it, and you can see the probability of those numbers. This tutorial was about basic image classification model in TensorFlow. If you like my video, you can subscribe to my channel. Thank you for watching.